Let's talk imaginary numbers a little bit. If you recall, I is equal to the square root of -1. You studied that in Algebra 2 last year. So, a few quick questions. What if I asked you to simplify 8 plus the square root of -16? Well, the square root of -16 can be broken up into the square root of 16 times the square root of -1. The square root of 16 is 4. The square root of -1 is I. 8 plus 4i would be your simplified answer. Remember, this is a complex number. It has a real part. It has an imaginary part. That should be familiar to you. All right. Second one here. If you had 12 plus 9i squared, and you were to simplify that, well, I squared would be the square root of -1 squared, which undoes the square root with the square there, so you're left with -1. 9 times -1 is -9 plus 12, leaves you with 3. Okay. One last one. Actually, no. I'm going to go on to number 18 in the book, which asks you to take a given, how does it say it here? It says complex number expressions can be multiplied using distributive property or the FOIL technique. Multiply and simplify the following. Right? So this is 18a. You would have 3 plus 2i times -2 plus 3i. So this should be fairly recognizable that we're going to FOIL. We're going to take the first times the first to get -6. We're going to take the outer, okay, first times the last one there to get 9i. Then we're going to do the inner, gives us -4i. And then we're going to do the last, which gives us 6i squared. These two are going to be like terms here. Those multiply together, add together to give you 5i. And then this here, this I squared, we know I squared is the same as -1. So 6 times -1 gives us -6. So now we have like terms with the first and that last one to give us -12 plus 5i. So you're going to get a resulting complex number here when you multiply two complex numbers together. All right, finally, this is a question that if you looked at the notes that I posted, it's on there, but I wanted to talk through it. What if I gave you two zeros that were imaginary zeros? 4 minus I and 4 plus I. Okay. And what if we need to write a quadratic function that had those two zeros for zeros? And then let's say we wanted to be concave up. Okay, so what we would do is we'd go to our quadratic function form, our factored form. Let's just make we want to be concave up, so a's got to be positive, and let's just make it easy. Let's just make a be 1. All right, we could put any number we wanted to, but 1 is easy. R1, there's going to be our first root. Notice the 4 minus I goes in for that first root, just like that. Our negative is still out front. Notice how I've put parentheses around the 4 minus I, times x minus the second root, which is 4 plus I. Just like that. Now, we're going to distribute our negative through here. So because it's going to be x minus 4 plus I. And distributing that negative through here, it's going to be x minus 4 minus I. Okay. So now we kind of have this trinomial times a trinomial. Okay. And it's our distributing. We call it FOIL when we do it with binomials, but you can do it with trinomials as well. Just take this first term times the first one here, x squared, first times the second one there, minus 4x, and then take that same one times the third term, minus xi. And so you're basically taking each term here times each one in the second one, and now we're going to jump to this one. We're going to take this one times each one in the second term. So we should have minus 4x plus 16 plus 4i. And then we do the same with the last one, the I times all of those. So that's going to give you plus xi minus 4i and then minus I squared. It gets to be a little long, right? But there we have it. Now we look and some nice things happen. Minus 4i and plus 4i cancel out. Minus xi and plus xi cancel out. And so we're left with x squared minus 8x. These are like terms. Plus 16 minus I squared. We can do a little bit more simplifying there. X squared minus 8x. That, right? I squared is a negative 1, so minus a negative 1 is the same as plus 1. Plus the 16 gives us plus 17. Okay, so you can write an equation when you're given the roots, even if they are imaginary numbers. All right, keep plugging away. Yeah, we'll talk to you later.